Okay, this video is about identifying the different types of intermolecular forces in a substance. All right, now we have ionic. Now, ionics, people might say, aren't really intermolecular forces, but the way that ionic compounds melt, you can think of it like that. So, if you had like sodium, a sodium ion will have an ionic bond, let's say, with a chloride ion, and in order to melt sodium chloride, you have to break this ionic bond. All right, so you can think of an ionic bond, even though technically it's probably not an intermolecular force, you can kind of treat it that way. All right, so with ionic bond, the easiest way to think about that to identify if something has ionic bond is a metal to a non-metal, and that's pretty much the easiest way to do it. Okay, there's also an ion dipole, which isn't really used too much for determining melting points or anything because it's not really between two of the same thing. It would be like when salt dissolves, like when sodium chloride dissolves, the sodium ions get torn apart from the chloride ions by water molecules, let's say. And so water is a polar molecule, and so a water molecule, which is H2O, it's going to surround and have an attraction. The negative end of the water molecule will be attracted to the positive ion. And basically you'll have water molecules surrounding and pulling the sodium from the chloride. Well, the sodium is an ion and water is a polar molecule, so it has a dipole. And so that's like the attraction right here between the ion and the dipole. All right, so that's what that is. That's not used too much with melting points. All right. Okay, hydrogen bonding is another type. Okay, hydrogen bonding, here's an example of water. And so water has these two lone pairs here. Now water will hydrogen bond with itself. You've probably seen that when you look at shapes of snowflakes and things like that, or drops of water, how water forms drops. But basically, water is attracted to itself with hydrogen bonding. And there's another video on hydrogen bonding you should watch that will explain it a little bit better. But the hydrogen bond is between two molecules, okay? Between the molecules, all right? And in order to qualify for a hydrogen bond, a hydrogen has to be sandwiched in between two fluorines, okay, two oxygens, or two nitrogens, or a combination of those. Here you can see that my hydrogen is sandwiched in between two oxygens. That qualifies as a hydrogen bond. So the hydrogen bond is between two molecules. So that's the hydrogen bond right there. You could also have, like, let's say ammonia, which is like this right here. It has a lone pair. Well, you can have an oxygen end of a water molecule will be attracted to the hydrogen end of an ammonia molecule. That's why when you pour them together, ammonia will dissolve in water because they form hydrogen bonds right here. All right, now you can see that this qualifies for a hydrogen bond because the hydrogen is sandwiched between, it's got to be sandwiched between any of these three, but it's sandwiched right here between oxygen and nitrogen. So that's a hydrogen bond. Like I said, there's another video that we have about hydrogen bonding that you definitely should watch. Okay, a dipole-dipole force. Well, a hydrogen bond is a type of a dipole-dipole, but a dipole-dipole force is an attraction between two polar molecules. Like if you had HCl, let's say, there's that molecule. The chlorine is more electronegative, so this side of the molecule is going to be negative, this side is going to be positive. Well, if another HCl came along, all right, so here's another HCl. Well, this side over here is going to be positive and this side is going to be negative. Well, this negative would attract this positive. And they call it a dipole, and sometimes they draw these arrows they call dipole moments that would go like that. They always point to the most electron density. But anyway, basically this side of the molecule is negative, this side's positive, so when you have two of those, this negative end would be attracted to this positive end on a different molecule. That's a dipole-dipole attraction. Okay, it doesn't qualify for a hydrogen bond because the hydrogen is not sandwiched in between FO or N. Okay, this up here is a special type of dipole-dipole, the hydrogen bond is, okay, where you have the hydrogen sandwiched between FO or N. And the last type of force is a dispersion force. Now, everything has dispersion forces. Okay, so even ionic compounds, anything that has electrons has dispersion forces. So with dispersion forces, to figure out which one would have the greatest, it's all done by the number of electrons. All right, so if you were to compare which has a greater dispersion forces, F2 or let's say Br2. Okay, well Br2 has more electrons, so it has the greater dispersion forces. So it's all about the number of electrons with dispersion forces. But everything has dispersion forces. Okay, ionics, ion dipole, hydrogen bonding, everything has them. Okay, but it's all about the number of electrons. All right, that's it for this video.